This video will review how to carry out our various solving algorithms for quadratic equations, with the wrinkle that all of the answers in this video will contain I. They will all be equations that have complex solutions. The answers will be imaginary complex numbers. So A, B, and C here, these first three examples, these are all examples of the square root method. We know they're square root method examples because they do not contain an x term. That is, their b value is equal to 0. They only contain an x squared and a number. So this process is very simple. Your steps are solve for x squared and then take the square root. That's it. That's all there is to it. So on letter A, we should be subtracting 36 from each side, which would solve for x squared. That would give us x squared equals negative 36. Now in a previous video, we talked about what happens when we take the square root of a negative number. In this case, the square root of negative 36. On the left side, we would just have x. And on the right side, if the square root of 36 is plus or minus 6, then the square root of negative 36 is plus or minus 6i. Same thing for letter B. We're going to subtract 100 from each side. That will give us 4x squared equals negative 100. Now you're going to be tempted to take the square root right here, but that is not solved for x squared yet. We still need to divide by 4. So divide by 4 next. Again, the goal is to have x squared equals a number, in this case negative 25. Then we take the square root of each side. And again, if the square root of 25 is plus or minus 5, then the square root of negative 25 is plus or minus 5i. Final example, we would start by adding 4 to each side, which would give us 3x squared equals negative 60. Then we would divide each side by 3, which would give us x squared equals negative 20. We take the square root, and in this case, 20 is not a perfect square. So again, we've talked about this as well. The square root of 20 is plus or minus 2 root 5. So the square root of negative 20 would be plus or minus 2i root 5. That negative on the inside simply becomes an I on the outside, and then we reduce the root like we normally would. The next algorithm we're going to review is completing the square. Now when we complete the square, we need to start in the form x squared plus bx equals c, because we will then add our blanks to that in order to complete the square. So if we look at letter D, it is not in the correct format yet. We need to subtract 61 from each side of the equation in order to put it in the correct form. So we do that first, which would give us x squared minus 12x equals negative 61. To that, we're then going to add a blank on each side and a blank on the next line. Some of you are still trying to avoid showing this work, and the end result is you are messing up the process. Please, just show the work. Now, we take our b value, we divide by 2. Negative 12 divided by 2 is negative 6. That goes in the bottom blank. Then we square that value, and we write it in the top blank. Anytime we square any number, positive or negative, when you square it, the result is a positive number. Negative 6 times negative 6 is positive 36. Now what we've done here is we've added 36 to the left side of the equation, so then we have to copy that 36 and add it to the right side of the equation as well. The final step then is to add negative 61 plus 36, which is negative 25. Now the end result is what has happened is we have taken our original equation and rewritten it as a problem that would be solved with the square root method. We have x minus 6 quantity squared equals negative 25. So our next step then would be to get rid of the parentheses by taking the square root. When we take the square root of the left side, the parentheses and the exponent cancel with the root, leaving x minus 6. And on the right side, we've discussed this before as well, the square root of negative 25 is plus or minus 5i. The final step then to solve for x would be to add 6 to each side of the equation. Notice I'm not writing that underneath the 5 because the 6 and the 5 cannot be added. They are not like terms. So our answer, and actually answers because there are two answers built into this, would be 6 plus or minus 5i, meaning our roots are 6 plus 5i and 6 minus 5i, a pair of complex numbers. You have to write the 6 first because complex numbers have to be written in the form a plus bi. Pause the video and try the next example, please. I will start it somewhere around the end of this sentence. Okay, we need to put it in the correct form first, so we would subtract 49 from each side of the equation. That would give us x squared minus 4x equals negative 49. We're going to add a blank on each side and a blank below. Then we're going to carry out our completing the square. Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. Copy that over to the other side. And we have negative 49 plus 4, which is negative 45. That means we have turned our equation into quantity x minus 2 squared equals negative 45, which we solve by taking the square root of each side. That would be x minus 2 equals plus or minus 3i root 5, because the square root of 45 is plus or minus 3 root 5. So the square root of negative 45 would be plus or minus 3i root 5. Final step, we have to add 2 to each side of that equation. Again, that 2 cannot combine with what is already there, as these are not like terms. So we simply move it to the other side where it becomes positive and write our answer 2 plus or minus 3i root 5. And that is what happens when we complete the square on an equation with complex roots. The final method we need to review is the quadratic formula. Quadratic formula, we found the discriminant first, was the way that we did it, and we did that for two reasons. We did that to make sure that we kept our mistakes to a minimum, and we did it because the discriminant tells us how many and what type of solutions we're dealing with. So first things first, to solve a quadratic equation, it needs to be in the form ax squared plus bx plus c equals 0. It has to equal 0 or you cannot use the quadratic equation. The quadratic equation itself is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the portion of that underneath the square root, b squared minus 4ac, that is what's known as the discriminant. And you need to find that value first. Need is a strong word, but in my class that's what I expect you to do. So we look at letter F and we say to ourselves, this is in the correct format. So what we need to do is identify A as being 1, because there's no number in front of x squared, which means there's an invisible 1. B is negative 3, and C is positive 4. B, C. Then we find the value b squared minus 4ac. That would be negative 3 squared minus 4 times 1 times 4, or positive 9 minus 16, meaning the discriminant is negative 7. Now again, we found that for two reasons. The main reason being that it reduces the chances that we're going to make a mistake when we try to do the entire quadratic formula. The other reason we do that is because if the discriminant is negative, which this one it is, then we know that our quadratic equation's roots, its two answers, must be complex numbers, meaning that we should expect to see I in our answer. Now we have not had any of those back when we did this in first semester because we hadn't learned about I yet. Well, now we have. So we are now going to go and plug into the entire quadratic equation. Negative b plus or minus the square root of that discriminant all over 2a. And that process is much simpler than it would have been if we had started that way because we already know this entire value underneath the square root. Now there is some you need to be very careful when you says negative b. This says the opposite of b. So since b is a negative number, when we plug it into the equation, that negative number would become positive. So negative b is 3. Plus or minus the square root of our discriminant, which was negative 7, that goes underneath the root, over 2 times a. 2 times 1. So we need to simplify that as much as we can. There's usually at least two things you have to do. One is consider how the root reduces. Root 7 does not reduce, but root negative 7 would be plus or minus I root 7. You can pull that negative out and turn it into an I. And then the other thing you can always do is multiply on the denominator. 2 times 1 is 2. So that would be our set of roots. 3 plus I root 7 over 2 and 3 minus I root 7 over 2. So we can keep those written as 3 plus or minus I root 7 over 2. We're actually going to do these out of order because if you feel comfortable, you can try the other two examples, but I'm going to do H next. So pause the video if you'd like and try to do H, and then follow along with me to see how you did. H is already in the correct format. A is equal to 7, B is equal to 10, and C is equal to 4. It already equals 0, so we don't have to do anything to it before we start. B squared minus 4AC, the discriminant is 10 squared minus 4 times 7 times 4. Excuse me. 10 squared is 100. Negative 4 times 7 times 4 is negative 112, which means our discriminant is negative 12, which again tells us that we have two complex solutions, and we should expect to see I in our answer. We then go to the quadratic formula, negative b plus or minus the square root of the discriminant all over 2 times a. The opposite of b would be negative 10 plus or minus the square root of our discriminant, negative 12, over 2 times a, which is 7. So negative 10 plus or minus the square root of negative 12 over 2 times 7. That reduces slightly. Root 12 is 2 root 3, so root negative 12 would be 2i root 3, and 2 times 7 is 14. Now we might be done here, but we might not be done here. If we look at this answer, you'll notice that the three coefficients, negative 10, positive 2, and 14, are all divisible by 2. So it is expected that you will realize that that is a fraction that can be reduced, and that you will divide those three coefficients by 2. So your final answer should be negative 5 plus or minus I root 3 over 7. Pause the video, try example G. G is also already equal to 0, so we're already ready to identify A as being 1, B as being negative 16, and C as being 73. So b squared minus 4ac, the discriminant, would be negative 16 squared minus 4 times 1 times 73. That would be 256 minus 292. That is negative 36. Again, that tells us that we are going to have two complex solutions. So we go to plug into our equation, negative b plus or minus the square root of the discriminant all over 2 times a. Negative b would be positive 16 plus or minus the square root of negative 36 over 2 times 1. So we have 16 plus or minus 6i over 2, because the square root of negative 36 would be 6i. 2 times 1 is 2. All three of those numbers are divisible by 2, so it would be expected that you would realize that that reduces to 8 plus or minus 3i over 1. Because it's over 1, we don't have to write the denominator, and our final answer would be 8 plus or minus 3i. I hope these videos are useful as you work your way through your homework and your IXL. Thank you for your time and attention.